Okay, we're looking at this right triangle. And it's important to note that this is a right triangle and it's from this because we're going to be looking at the tangent ratio. And the tangent, you can only do that if you have a right triangle. So we are asked to find the tangent of two different angles of D and F. Now those are the acute angles in this triangle. So that is this angle right here, D. So we'll do this guy here in the yellow. And then we're going to talk about the tangent of F, which would be this acute angle right here. So I'll highlight that one kind of in green. We'll do each of those. Now, it didn't say E, and it doesn't say E for a reason. We actually do not do the tangent of a 90-degree angle. It's always going to be from the acute angles in the right triangle. We'll talk about why a little bit more in integrated 3 when we get into the unit circle. But for right now, just know that we're only going to do these two. Okay, so what is the tangent ratio? The tangent ratio in general, I'll put this here, tangent of an angle, right, is going to be, we've talked about it as a slope ratio, so you can think of it as the rise over the run. But we're really going to try to transform our thinking more into what we call the opposite over the adjacent. So meaning as we go through the triangle, we're going to look on the side that is opposite the triangle and the side that is adjacent. And notice we are not going to use the hypotenuse. So at no point in all of these will we use the hypotenuse at all. That one is going to be off the table, so to speak. Okay, so let me zoom out just a little bit so we can kind of see all of this here together. Good, we are asked to find the tangent of D. So from angle D, the tangent of D, so it's always the tangent of an angle. This is angle D here. Now, just to keep in mind, we are not going to be using 25. This will not be a side that we use in that ratio because that is the hypotenuse. It's always going to be these two sides. And if we think about this in terms of a slope ratio, like if I turn this thing around, right, and look at it here, I can think about it as rise over run. But we want to avoid having to turn our triangles anymore. So we want to think about it as the side that goes through the triangle, the opposite leg, and then the adjacent leg. So the one across and then the side next to it. And again, never using the hypotenuse. So all this is going to be is 7 over 24. And that is the first answer. You were asked to find the tangent of D as a fraction, and then it also wanted it as a decimal. And I believe if you're doing the 9-4 exercises, it wants it to 3 decimal places. So we'll just do 7 divided by 24, and that'll be approximately 0.292. Now remember that rounding, right? There's a 1 there, but that 6 tells me to round up, and arguably I should change that into an approximately equal sign. All right, if we do the same thing here with the tangent of F, right? So now we're going from this perspective. So now we're going to do the opposite side from F. So it's going to be 24 over 7. And then we're going to throw that into the calculator. 24 divided by 7. That is about 3.429. That up just a little bit. 3.429. Now, a couple things to note here as we are compiling our final answers. Tangent of D, here it is, as a fraction and then as a decimal. Notice that D and F are complementary angles, meaning that they sum to 90, and I know that because these two together plus 90 has to be 180. So if I start at 180 and take off 90, there's only 90 degrees left here. So D and F are complementary angles. Now check out their tangent ratios. One is 7 over 24, and the other one is 24 over 7, and that is not a coincidence. That will always happen. Complementary angles, like D and F, are going to have reciprocal tangent ratios. Okay, I might even just jot that down here. Complementary angles, and then I really hope I'm spelling this right. Complementary angles, and in this case that's D and that's F, will have reciprocal slope ratios. Right, in this case, 7 over 24 and 24 over 7, respectively. Okay, I hope that's helpful. Message me anytime with questions. This is really just knowing about what the tangent ratio is, that it is the opposite over the adjacent. Right, so the rise over the run if you're thinking about it as a slope ratio, but we want to get to the point where we are not turning the triangle, so it's opposite over adjacent. Again, never the hypotenuse, not the hypotenuse. And then we just get that ratio, and we can divide it out to get the decimal if we wanted to, or just leave it as a fraction. And this is an important piece of info too. Message me anytime with questions.